video we will solve a problem on production with three inputs. The question is, a firm uses three inputs K, L, R to manufacture its final product. The prices per unit of these inputs are $20, $4 and $2 respectively. If the other two inputs are held fixed, then marginal product functions are, that means marginal product of K, let us say K is capital, is being given as 200 minus 5K. Marginal product of labor is equal to 60 minus 2L, and marginal product of R is any other input, okay, which is equal to 80 minus R. These are the marginal product functions. We have to find out what combinations of inputs should the firm use to maximize its output if it has a fixed budget of $390. Okay, so what we are being given, and let's write it here. We are being given the price of price of capital is being given as is $20. Price of labor is equal to $4, and price of another input, which is R, is being given as is $2, and total budget, okay, let's write it here. Income or budget is being given as is $390. Okay, now given these values, also we are being given the marginal product of capital, marginal product of labor, and marginal product of other input or, okay. Now the basic rule for optimal input determination is that the last $1 spent on each input should add the same amount of output. Okay, so that means what we optimal combination input determination requires that our marginal product of capital upon price of capital should be equal to marginal product of labor upon price of labor should be equal to marginal product of R, which is another input, upon price of R. Okay, what does this tell us? It simply tells us that for optimal input determination, okay, the last dollar spent on each input should add the same amount of output. So this condition must hold. Now what we are being given here, marginal product of capital, which is being given as is 20 minus 5K, and let's write it here, 20 minus 5K upon price of capital is being given as is 20, should be equal to marginal product of labor is 60 minus 2L, and price of labor is being given as is 4, should be equal to marginal product of R, that is 80 minus R upon price of R, which is being given as here 2. Okay, now what will we do here? We equate the first two terms first. Okay, so if we cross multiply here, it will become 4 into 20. Okay, it is here 200, sorry. So 4 into 200 is 800. Okay, minus 4 5s are 20K, should be equal to, so 20 into 60 comes out to be 1200. 20 into 2 comes out to be minus 40L. Okay, first we equate these two equations, these two relations, then we equate these two relations. Okay, so this is one equation, and if we solve it, or let me write another equation here. So now we also equate these two these two relations here, that is 2 into 60 is 120 minus 2 into 2 is 4L, should be equal to 4 into 80 comes out to be 320 minus 4R. Okay, let us solve this function first. So this becomes 40L. If I transpose it here, it will become positive. 40L minus 1200 minus 800 comes out to be 400, should be equal to 20K. Okay, and solving for K, we can factor out 20 from both sides, so this will result in K is equal to, so 40 into L If we take 21s are 22s are, so we will get here 2L minus 20 into 20 is 400, so we will get this relation. So K is equal to this. We have solved K as a function of labor, and here we will solve R as a function of labor. Okay, so solving it, it will give us so our 4R will be equal to, if I transpose it here, it will become positive, should be equal to 320 minus 120, it comes out to be 200. Transposing, it will become 4L, so 4 200, so we can divide both sides by 4, so we will be left with R is equal to 4 5s are 20, so 4 zeros are 0 plus L. Okay, this is first equation, this is second equation, and now let's write the budget constraint what is being given us. So our budget constraint is, that will be our third equation. So what is our budget constraint? Let's write it here. For that, let us use the proper color here. Okay, our budget constraint will be price of capital times units of capital plus price of labor times units of labor plus price of R, which is another input, times units of R, should be equal to our budget, that is M. So price of capital is being given us as 20, so we have 20k plus 4L in place of price of labor, we have 4L plus 2R should be equal to our M is being given us as 390. So let us say this is third equation. What will we do? We will substitute equation first, second in equation third. Okay, so we have 20 here. In place of K we write 2L minus 20, so we have 2L minus 20 plus we have 4L plus 2. In place of R we have for 50 plus L, 50 plus L should be equal to 390. So this becomes 20 into 2 is 40L, 40L minus 400 plus 4L plus 250 is 100 plus 2L should be equal to 390. Okay, so we have 40L, 4L and 2L, so 40 plus 4 is 44, this comes out to be 46L. 46L should be equal to 390. Transposing this, it will become plus 400 and 100 will be subtracted, so this comes out to be, and let's write it here, 46L comes out to be 4 गए 7 8 minus so this comes out to be 690, or L is equal to 690 upon 46, which gives us L will be equal to, L will come out to be, I have calculated the value of L, it comes out to be 15. Okay, 690 upon 46 comes out to be 50. That means we need 15 units of labor. Okay, now how many units of capital we need? Simply plug the value of L which we got here in the first equation, it will give us the units of capital optimal combination. That means K will be equal to 2, the value of L is 15 minus 20, so K comes out to be 215 is 30 minus 20 comes out to be 10. That means units of capital that we require is equal to 10. Now we need to find out the units of R. Okay, so units of R will be equal to, so just plug L is equal to 15 in this equation, that means our R will be equal to, so let me write it here, units of R will be equal to 50 plus the value of L we got 15, that gives us R will be equal to 65. Okay, so we got the three optimal input combinations is, we need 15 units of labor, 10 units of capital and 65 units of other input, which is R here. Okay, I hope I make myself clear in this video. Thank you.